So when I say a power function, do you guys know what that looks like?
No.
We've seen some of them. X squared, x cubed.
Oh, like power.
Yeah, if it's just x to some kind of power, I'll just call it b. That's a power function. X to any power. A root function is like, I'm going to say an nth root of x. So it could be a square root, it could be a cube root, it could be a fourth root, anything like that. These things are related. There are power functions that are also roots. If, for instance, you had x to the 1/3 power. Okay, that's a power function, but how could you rewrite a 1/3 power?
3
Yeah, so your 3 goes on the outside, it's called your index, or it's telling you you have a cube root of x. So there are some power functions that can be written as a root. In general, if your power is a fraction, you could write it as a root. So if I said like x to the 5/4, how would you write that as a radical? The 4th root of x to the 5th. You can actually put the 5th under the radical or outside the radical. Most of the time I'll probably put it outside, just because if you have numbers that you're dealing with, I like to get a smaller number before I take it to a big power, but it really does not matter. Okay, so let's talk about these. If you have a root function, we can't do like the square root of just any number. You know, I can do the square root of 6 and get a decimal, but if it's a -6, what kind of answer do you get? An I. So if I'm talking about real numbers, we have to kind of decide what kind of things can go under a radical. So if you're talking about a root, we have two cases. If it is an even root, so that means like a square root, 4th root, a 6th root, so on. So if you have an even index, an even root here, what kinds of numbers can be under that radical? Positives, right? If you had a negative, you would get an I. So the domain would be bracket 0, comma, infinite. You could only have positives under there. If we are talking about an odd root, so like a cube root, 5th root, 7th root, and so on. Can you do the cube root of 8, for instance? Can we do the cube root of a positive? Yeah, cube root of 8 would be 2. 2 to the 3rd power is 8. Can you do the cube root of -8? What does it equal? -2. So if it's an odd root, you can have positives or negatives under there, so your domain is everything. So when we're talking about these domains, you'll have to look on your index, on the root itself, and see, are we dealing with a positive or negative, which will tell us what kinds of numbers we can put in. All right. I would like to just start simplifying a few radicals, working through those, making sure we understand what these mean. Okay, the cube root of 27. Just means what to the 3rd power equals 27? You can do it on your calculator. I want to caution you, Eventually we're going to have variables with this, so make sure you understand what it means. Don't just always go to your calculator to do that. But to do the different roots, if you go into math, you'll notice like number 4 is a cube root. Number 5 just has like a little x outside there. If you wanted to do like a 4th root, so if I wanted to do b here, I would have to put in the 4, then go to math, number 5, and then type in the 10,000.
And what about the negative?
Okay, so this,
Could you just take it and then put a negative in front of it?
yeah, the negative is outside, so all that means is my answer will be negative. You can have a negative outside your radical, it just stays, and then the 4th root of 10,000 is? Okay. So negative 10 is our answer.
I like this one. Can I stay here?
Okay, C, the cube root of negative 216. Can I have a negative under there? Yes, because it's an odd root. That's okay. So what to the 3rd power is negative 216?
6. So negative 6.
Negative 6.
So it doesn't matter if they're inside or outside, they're going to be negative as a negative.
You do have to watch. So if it's an odd root, it can be inside, but like on D, if I said the 4th root of negative 81, yeah, what happens if you type that one in your calculator? The 4th root of negative 81? Error.
So it's only with the
Yes, only with the odd ones that you can have a negative under there. With this one, it's not going to be a real answer. What's going to come out of that? It would have an I. What is the 4th root of 81? 3.
Well, we have to put plus and minus.
No, you put plus or minus if you add the radical. If the radical is already in the problem, you do not. Okay. With fractions, obviously if you have a calculator, you just type in the fraction. But if you were trying to do it by hand, all you do is the top and the bottom. So what's the cube root of 125? What to the 3rd power gives me 125? 5. Over, what is the cube root of 512? What to the 3rd gives you 512? 8. Okay, so if you're trying to do those by hand, you just do top and bottom separately. F. Can we have a negative under this one? Yes. Okay, I have a negative on the outside, so that would stay. And then what's the 5th root of negative 243? It would be a negative 3. So 2 negatives would make positive. Positive
Could
3.
we just go ahead and write?
Oh, absolutely. Okay. So far, so good? I'm going to give us some more with numbers. But instead of you just typing this in as it's written, I want to see if we can figure it out. Kind of preparing us for when we have to do this with variables. If I just look at 16 to the 3/4, I don't really know what that means. But how could I rewrite 16 to the 3/4 power?
4 of 16 to the 3rd.
Okay, and I'm going to put the cube on the outside. What is the 4th root of 16? 2. So then you have 2 to the 3rd power, which is 8. On B, this one was already written as a radical. The cube root of negative 64. Negative 4. So we have negative 4 to the 4th. And if you need to use your calculator, have a little trouble with that, you may. What would that give you? Good. Make sure, if you are using that calculator, the negative is in the parentheses. So the 4th power applies to that, which turns it positive. All right, C. Let's rewrite this one for a minute. We know exponent rules. It doesn't change anything if they're fractions. If you have a power to a power, what do you do with those exponents? Multiply. So 3/4 times 2, 3/2. Then how would we write that?
Square root of 25.
Square root of 25?
5.
5, and 5 to the third. So 5 times 5 is 25, times 5 is 125. Okay, last one of these. -8 to the 5/3. What would we do? Cube root. Okay, what is the cube root of -8? And -2 to the 5th. Do you guys understand the process, how we are going through this? So now, let's simplify some with variables in them. Okay, if I gave you the 5th root of x times the square root of x to the 3rd. Why don't we rewrite these? What is a 5th root? How would you write that? X to the 1/5 power. How would you rewrite the square root of x to the 3rd? So 3/2. Good. Exponent rules. If we are multiplying, if the base is written each time, you add the exponents. So 1/5 plus 3/2. 17/2. Technically, it's equivalent either way. If we left our answer like this, that's fine. If you wanted to rewrite it in terms of a radical, how would you write that? Okay, so you could write your answer either way there. The homework is going to be Math Excel, so you just have to watch on it. It'll tell you, write your answer as a radical or write it with integer exponents, so just watch the directions. Okay, I'm going to do C with you actually, and then I'm going to have you guys do D and D on your own. So jumping down to C here. It's a cube root, and then under the cube root you have an x squared times the 7th root of x. Okay, so the whole thing is to the cube root, which is like what power? 1/3. And then inside we have x squared times the 7th root of x, that would be x to the 1/7. Okay, let's just work on the inside for a minute. If I am multiplying there, what do I do with those exponents? Add them. So 2 plus 1/7. And then, what do I do with my exponents? Right, power to a power, you multiply, and you get x to the 5/7 power. I would like for you guys to try B and D. So first one, you write it as 4/3 and 5/4. And since your x is written each time, what'd you do with those? Add them. What'd you get? 31/12? You can,
It's just a show.
yeah. In general,
That's funny.
I will specify, like on the test or quiz, you know, write it as radical or.
I put that the 4 was an exponent to the x
Oh. It's kind of hard to tell. They're a little close together there.
We'll redo that.
Okay, this one, it's all under a 6th root, so it would all be to a 1/6. This is an x times the cube root of x squared, so that's x to the 2/3. With these x's, you add their exponents, so 1 plus 2/3 would give you 5/3. So you get x to the 5/18. Alright. So other than not reading the original problem correctly, are there any questions? Yes. Okay. You distributed and then combined, that is fine. Any other questions? Yes. It's okay. Yes, ma'am.
On the first one, whether it's second year.
I just got 23 and 45. I didn't see this.
Okay, that would make sense. And if I ever give you a radical without a number, what does it assume? Like if I gave you x this, how would you write that?
5/2.
5/2. If I don't give you the index out here, it's assumed to be a 2 for square root. Okay. Well, one last thing that I want to talk about. We need to talk about our domains. I guess 2 things. We're going to talk about domains and some transformations, and that'll wrap this up. Domain, we already said at the beginning how we find these domains. If it is an even radical, what has to be true about the thing underneath? So if I'm looking at this, I just have to take the thing under my radical, so 4x plus 12, and that's greater than or equal to 0. And then I'm solving this inequality. So I subtract my 12, divide by 4. Keep in mind if it were a negative, you would flip your inequality. And then I want you to finish this in interval notation. So greater than or equal to 3 would look like what? Bracket, because of the equal to, 3, comma, infinity. That means you can plug 3 or any larger number in there.
Would it be negative since you subtracted it?
Oh, it would, thanks. I was talking about my negative and I didn't write that. Alright. Anything else there? So what about b? It's a cube root. Right. If it's a cube root, we can have positives, we can have negatives. So what did we already say the domain always was for those? If it's an odd root, you don't have to work out anything. You just say negative thing to infinity. But if it's an even root, then you say whatever's underneath greater than or equal to 0. And if there's other stuff, you know, if I had like a negative out here and a plus 5 on the end, it doesn't change. All you look at is the part under the radical. Anything else?
If it's the way you talk it's an even, if it's like square root, fourth root, sixth root, and then 8 pi is third root, then
Exactly. Anything else? Last thing. So, we have done transformations before. I am giving you a radical, And I want to know how we could use transformations to graph this. What we are going to do is start with the square root of 4x plus 12. Do you notice anything about 4x plus 12? Can I pull anything out of that? Okay. If I take out a 4, that would leave me with x plus 3, correct? This is a square root. Can I do the square root of the 4? And that would be 2. So a 2 comes out because I evaluated the square root and the rest stays underneath. Okay, now we're in perfect shape to describe our transformations. If you have a number on the outside, what does that do? Stretch or shrink, right? It's outside, so it's vertical, and vertical does what we think. So this is a vertical stretch by 2. If it's outside, a number bigger than 1 stretches, a number smaller than 1 shrinks. It's like taking your height. So if I take my height times 2, I get taller. If I take my height times a third, I get shorter. And what would the plus 3 do? Okay, and that's it. I didn't ask you to actually draw it, I just asked you to describe. No. Just ask you to describe them. We graphed these back in chapter, I don't know, 2, 3. We did our transformations and we did them with radicals then. Really what we're just practicing right now is manipulating that equation so you can identify your transformations. Okay, last one. Okay, this one is a cube root instead of a square root, but same principle, our transformations don't change. We start with the cube root of negative 8x plus 8. What would you pull out of that? And that leaves you with x minus 1. Okay, so can we do the cube root of negative 8? And that is? So negative 2 comes outside, and we have the cube root of x minus 6. Okay. There's 3 things going on. What does a negative do? Flips. Negative flip. It's like making your y's negative, so it flips over the x-axis. What does the 2 do? 2 is bigger than 1, so it is a stretch. And what's the minus 1 do? Right.
So the negative and the 2 are separate.
Yes, because the negative causes the flipping.
And then
So then you're just looking at the positive 2. Does it stretch or shrink?
So what if it was negative like 1/3, then it would have shrink it?
So it would be still a flip over the x and then vertical shrink.
When you said vertical shrink.
This is a stretch because 2 is bigger than 1. She was asking if it was. The negative is what flips it. So you essentially are looking at 3 separate things. You are looking at a negative, you are looking at a 2, and you're looking at the 1. Yeah. If there were a negative left on this x, but we're going to try to pull those out whenever possible, so it's a little easier to think about. Other questions? That is the end of this section. So there is a Math Excel assignment It's a few more questions than I usually give you, but if you go through them, a lot of them are really fast. You know, what's the cube root of 216 and things like that. So it should go fairly quickly.